Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be solving a nice expression equation with complex numbers. Now if you're new to complex numbers, go ahead and check out my lecture videos. If you like algebra, number theory, and trigonometry, then this channel is for you. It's called Cyber Math, that is cyber with an S. Now, we are given an equation, an expression for z, which is z minus z squared equals 1. Based on the values of z from this equation, we're going to evaluate the second expression. Okay? So, how do we do this? We can do this in many ways. Let me go ahead and introduce at least two different methods. So, our first method is basically going to be depending upon solution of this equation. So, let's go ahead and start by solving this equation. How do you solve an equation like this? Well, I hope you noticed that this equation is quadratic. So we can go ahead and put everything on the same side. Right-hand side is better because that's where z squared is positive. Now we get a full quadratic. And why do we have a quadratic formula? To solve quadratic equations. Exactly, right? Let's go ahead and use it. Z equals negative b, which is 1, plus minus the square root of b squared, which is 1, minus 4ac, which is 4. 1 minus 4 is negative 3. And then we get a complex solution. Of course, this channel is all about complex numbers. That's why we did get a non-real solution. What's the square root of negative 3? It is the square root of 3 multiplied by I with a plus minus sign, but we already have that. So we can basically go ahead and write the solution like this. Now, here's a $1 million question. I need to evaluate an expression in z, which is the 11th power and the 7th power added together. Which z value am I going to use? The answer is, it shouldn't matter, right? Hopefully. If the problem was constructed properly, then it should not matter because this is basically covering both values of z, right? The second expression, nothing was specified, so we should be allowed to use any value. But since I have that type of freedom, let's go ahead and use the one with the plus sign, which seems a little nicer. Don't you think so? Now, let's go ahead and plug this in. But wait a minute, how am I going to find the 11th power of this number, right? So here's what I need to do. If this is z, then I need to find the 11th power, I need to find the 7th power, and then I need to add them. Isn't that going to be a lot of work? I mean, consider the binomial theorem with n equals 11. That is going to be 12 terms, and this is going to be super duper painful. One thing that might make your job a little easier is you may want to try to factor z to the 7th out. That'll give you z to the 4th plus 1. So at least you're only going to need to go up to the 7th power, but you still need to do the 4th and the 7th. But once you get to 7th, you'll already have the 4th, hopefully, somehow. And then plus 1, so on and so forth. So this seems a little easier, but again, a lot of work, don't you think? But let me just show you real quick what that looks like. So we're going to take this number, the z value we chose, right? We're going to take that, and don't forget the 2. We're going to raise it to the 11th power, but in this case, we can use the 7th power. And then we need to take that and raise it to the 4th power and plus 1, and whatever comes out of that, we're going to multiply by the 7th power. But there might be an easier way to do it with the 7th power. For example, you can try to square it first, right? And then cube it. Let's square this number. We're going to get 1 minus 3. Oopsies, I forgot to say I squared is negative 1 because I is the square root of negative 1. So from here we get negative 3 plus 2 root 3i divided by 4. That's definitely a negative 2, and this will give us negative 1 plus root 3i over 2. Isn't that weird? Like the square of this number kind of looks like the number, but it's not the exact same one. It is kind of like a I would say maybe a conjugate, or, you know, it's kind of modified a little bit. But you get the idea, they're related. Okay, the next thing you can do is you can try to cube this, right? You can take that and cube it, which is going to give you the 6th power of z, by the way. And then multiplying by z again, you're going to get the 7th power. And to cube this, you can use the formula, so on and so forth. But again, this is a lot of work, don't you think? So there must be an easier way to do it. This is not the way to go about it. So you don't want to take this number. Now, this number is actually super duper special. Let me tell you that. And so we can use that to our advantage. So what is that number again? Z equals 1 plus root 3i, 1 plus root 3i over 2. Now, if you look at it very carefully, first of all, separate the real and the imaginary parts. And what are you going to realize? You're going to realize that any complex number can be written as cosine theta plus I sine theta, thanks to Euler. But we also have something called the modulus, so it's r. And then this x part can also be written as e to the power I theta, which is an exponential. Great. But in this case, r, the modulus is 1, because if you do the math, you're going to realize r is 1. So we can directly set this equal to cosine and sine of an angle. And you hopefully know from trigonometry. If not, go ahead and check out my playlist, which I made on Cybermath, the other channel, my very first channel. Go ahead and check it out, and you'll find a lot of trigonometry videos. And you know what? At some point, I'm thinking right now to myself, and I think I should make some lecture videos on trigonometry, don't you think? A lot of people need trigonometry for their classes, and I think it'll be a good foundation. Well, let's see if I can find time for it. I'll try to start doing it. Anyways, in this case, cosine of 30 is root 3 over 2, so this will be cosine 60, which I know can be written as cosine pi over 3, and this can be written as sine pi over 3. And what does that mean? It means that cosine pi over 3 plus I times sine pi over 3, magically we switch them around, can be written as e to the power I times pi over 3. Now, what is so good about, like, why are we obsessed with the exponential form, right? Because it's very easier to exponentiate. Duh. I mean, if you have an exponential, you can exponentiate it further, right? So here's what we're going to do. We need the 11th power and the 7th power, and I don't really care about factoring. 11th power is super easy. So z to the 11th power is just going to be e to the power I times pi over 3 to the 11th power. And by you know that by rules, this is going to be e to the power I times 11 pi over 3. Obviously, 11 pi over 3 is greater than 6 pi over 3, which means it contains 2 pi. Throw away the multiples of 2 pi. You're going to get e to the power I times 5 pi over 3. And that's when you get the value. Now, let's do the same thing with the 4th power. Was that the 4th or the 7th? I got confused. Yeah, I used the 4th to factor. 7th, wait, is that 7th? Actually, never mind. I confused myself twice, so I wasn't confused originally. So that's the 7th power. So do the 7th power. We're going to go ahead and take this and then raise it to the 7th power, which is going to give us e to the power I times 7 pi over 3. As you know, 7 pi over 3 is still greater than 2 pi, which is 6 pi over 3. That leaves us with e to the power I times pi over 3. Uh-oh, this is interesting, don't you think? I raised z to the 7th power, but then I got z again. Why? Because this is a cycle. It's cyclical. Okay. Now, let's go ahead and take these two expressions and add them, because that's what we're supposed to do. Z to the 11th power was, wait a minute, where was it? I lost it. Okay, e to the power I times 5 pi over 3. So what's 5 pi over 3, right? It's 5 pi over 3 less than 2 pi. So it's going to look like this. We have the 60 degrees. This is 5 pi over 3 or negative pi over 3. You get the idea? Same thing. And of course, its cosine is going to be the same as cosine pi over 3. So this is going to be cosine 5 pi over 3 plus I times sine 5 pi over 3. Cosine 5 pi, cosine is like a tongue twister. Cosine 5 pi over 3 is the same as cosine pi over 3, which is 1/2. But this is a negative because we're in the 4th quadrant. Therefore, you're going to have something like this. This is the 11th power. And remember, for the 7th power, we got the same number. And when you add them, guess what's going to happen? Ta-da-da-da. The i's are going to cancel out, and we're going to end up with 1. Okay? Good old 1 is going to be the answer. Now, this was just the first method. I hope you enjoyed it, because we're not done yet, and continue with the second method. Okay, what was the problem? The problem was z minus z squared is equal to 1, and then we're supposed to evaluate this. Okay, you already know the answer, so it's not fair. But suppose you started with the second method, maybe some of you did, and hopefully you're going to see this first, and then watch the first method, okay? Now, and if somebody can make, what's it called? Table of contents? Like chapters, yeah? When you write them as by minutes, I think timestamps or something like that. Anyways, you get the idea. Hopefully someone can do it for me. I know I have a beautiful audience. Hopefully someone can do it for me. Please do it. Now, Wait a minute, did I say it's equal to 1? No. Okay, you didn't see that, did you? So here's what we're going to do. From here, it's still visible, so let's hide it. Okay, our goal is to find this. Okay, how can I do this using a different method? So here's what I can do. Instead of trying to solve for z, I think this is a really cool idea. Put the z squared on the right-hand side, bring the 1 over to the left. So in other words, write the equation like this. It's the same one, right? Now, this is good for many reasons. I know a formula, so kind of like maybe we should call this linearization of a polynomial or something like that. I don't know the proper term, but you get the idea. We can express z squared as a linear expression. Can we do the same thing for z cubed? Absolutely, because z cubed is just going to be z squared times z, which is z minus 1 times z, which is z squared minus z, which is z minus 1 minus z, which is negative 1. This is interesting, don't you think? Z cubed equals negative 1. Now, this makes things a lot easier. You know why? Because you can just take it and square it. Obviously, z to the 7th is z cubed squared times z. And now this becomes negative 1 to the 2nd power times z, and that gives us z as before. We already talked about it, right? 7th power of z is the same as z. What about the 11th power? Well, maybe we can do the 3rd power and then multiply it by z squared, or you can do the 4th power and divide by, I'm not sure if you want to do the 4th power because then you'll have to go backwards, divide by z. That's a lot of work. Let's not do it because we're lazy. I'm lazy at least, right? Negative 1 to the 3rd. Oops, I got the connection again. Times z squared. But what is z squared, right? Well, if z is this, then I can easily square it, can't I? If you square the first number, you get 1/4, and then 3/4, and then 2 times 1/2 times root 3 over 2i. These two cancel out. We end up with negative 1/2 plus root 3 over 2i. Okay? Negative 1/2 plus root 3 over 2i. That will be z to the 11th power. But this is negative 1. So we're going to have to negate this. Z to the 11th is going to be then 1/2 minus root 3 over 2i. Z to the 7th is the same as z 1/2 plus root 3 over 2i. Add them up and you will get 1 again. All right? So obviously, you don't have to do it this way. You could also proceed like, okay, what is z to the 4th? What is z to the 5th? What is z to the 6th, 7th, so on and so forth. And you can find a linear expression for each one of these. But here's what you're going to find at the end. You're going to find z to the 11th is equal to, okay, let's do this. So if z to the 3rd is negative 1, okay, and I want to find, let's say, since I need 11, I'm probably going to need to cube this. Okay. And that gives us z squared. So we have to go by z squared anyways, right? So z to the 3rd times z squared. This is negative 1, so it's negative z squared. And as you know, z squared is equal to, what was it? Z minus 1, so this is going to be 1 minus z. Beautiful. I think this is going to be helpful. This is z to the power 11. And then z to the power 7 is z cubed squared times z. As you know, z cubed is negative 1, so this is z, and then this is z. So when you add them, you get 1. Again, no matter how you approach it, you're always going to get 1 as a result. And there's probably more ways to do it, but I'm going to stop here because this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care. Don't forget to check out CyberMath, Short Channel, and aplusbi, and bye-bye.